Hi everyone! Today we're going to be going over the 2022 AP BC Calculus Answers for FRQ number 5, and let's get started into the video. Just a quick reminder that you can access these questions in the official PDF, which I have linked in the description box down below, or you can copy the link in the video shown right now and put it into your search bar. Just wanted to also mention that this is not affiliated with the AP College Board. This is just a video going over all the answers, which we'll do right now. First is question 5a. So we have these two regions bounded by certain functions and certain axes, and it looks like the first one is completely bounded, whereas region W, or the second region, is not bounded on the right side. So for question 5a, we're asked to find the area of region R. So my area is going to be the integral from my bounds, so that's from 1 to 5. And because this is a function of x, we're going to do top minus bottom. So my top is going to be 1 over x, and my 0 is going to be the bottom. So we're going to minus 0, so it's the same thing. So the integral of 1 over x is going to be the ln of x, and remember that the derivative of x is 1 and 1 is on top, so it would be the ln of x. And then you want to evaluate it from 1 to 5, and then I'm just going to place in 5 in for x, and then 1 in for x as well, and subtract it from each other, and this would be your answer. And you don't really need to simplify it, but if you did using log rules, then it would be ln of 5 over 1, because it was subtracting before, and you end up getting an ln of 5. So either way, you should still get the point. And for the points, I think it's going to be a point for the setup, and then another point for plugging in the 1 and 5 to get an actual answer without any variables, and it can be simplified or unsimplified. Next is question 5b, and we have to find the volume given that the area is xe to the x over 5. So this is going to be perpendicular to the x-axis, which means that we can use this equation to solve for the volume given area. And so my volume is going to be from bounds A to B of capital A, which is my area. And my area given is in the problem, and that is of course, xe to the x over 5. And so I can substitute that in, and since this is region R we're looking at, well then my bounds from A to B are actually going to be from 1 to 5 instead, and I'll just substitute that in. Now here's the final equation, and we have to integrate it. But looking at this, we can't really do anything unless we do uv minus vdu or integration by parts. So I'm going to set u equal to the simplest part, which is x. My du is the dx. The v is the more complicated part, or e to the x over 5. My dv is the more complicated part. And then to get to v, you have to integrate the dv. And then you get your v as 5e x over 5. Now we have to just place it into the equation, so I'm going to take the u and multiply it by the v, minus the integral of v du, which is the integral of 5e x over 5, and then my du, which is just dx. Now I'm going to separately solve the integral of 5e to the x over 5, and that will be and I'm just going to add that's going to be the 25e x over 5, and then I'm just going to add in the x 5e to the x over 5 right in front. And so now we're not quite done yet, because remember that we still need to evaluate the entire expression from 1 to 5. I always forget this part for some reason, so make sure that you don't. So we're not quite done yet. And so I'm just going to evaluate it, plugging in a 5 into the expression. We get this, so 25e minus 25e minus, and then you substitute all the x's for the 1's as well, which if we do that, we get 5e to the 1/5 minus 25e to the 1/5. And what's really nice is that the 25e minus 25e will cancel, and you get a flat 0. And then 5e to the 1/5 minus 25e to the 1/5 is going to be negative 20e to the 1/5. But there's still a negative out in front, so that's actually going to be a positive 20e to the 1/5. And so your final answer will be 20e to the 1/5 power. Now for points, it's going to be a point for the setup, a point for the integration by parts, and another point for evaluating it from 1 to 5 to get your answer simplified or unsimplified, as long as there are no variables. Now, for the last part, or for part 5C, we need to find the volume generated around the x-axis for the unbounded region W. Looking at this, we know that W is in terms of x, so it'll have a bunch of x slices revolving around, and then the x-axis is parallel to those x slices, and so because both of these are now perpendicular to each other, my teacher had this fun saying. I don't know if my teacher made it up or if this is an actual thing, but if the x slice and the axis is perpendicular with each other, then it will be perpendicular, which means we have to use a disk formula and not a shell formula. I use this like mnemonic type thing so much, and it's super helpful, so keep that in mind. Um, and it's also not revolving around some line, so it won't be a washer either, so it must be a disk. Okay, and so for that equation for the disk, it will be this, where r is the top minus bottom equation. So that would be the volume is equal to pi, and my integral bounds are actually going to be treated like an improper integral, since it is an unbounded region. So it's going to be from 3, and notice how on the right side it is unbounded. And so, there's no bound that we can work with, so it'll be 3 to infinity, because it'll keep going on forever. And for the r, like I mentioned before, it will be top minus bottom, or 1 over x squared minus 0. But since it's r squared, you have to take that entire thing and square it again. And now, because we're dealing with infinity as a bound, we must set it as some variable to make it actually work. So I'm going to set it to be as approaching infinity, so the limit as b approaches infinity. And you can really use whatever variable you want. I'm just using b just because I've always used it and I've learned it that way. And then you're going to take the limit of something, which that's going to be what's above, and the top bound of infinity will be replaced by b, and we're taking the integral of 1 over x squared squared, which is also the same as 1 over x to the fourth. Now, just simply integrate it as if b were to be an actual number, so you will get negative 1/3 x to the negative 3 multiplied by pi, all evaluated from b to 3. And now just plug in b and 3, so it'll be pi multiplied by the negative 1/3 b to the negative 3, like this, and then minus negative 1/3 multiplied by 3 to the negative 3 power. Okay, wow, that's like kind of confusing. But anyway, if you do simplify, it'll be the same as negative 1 over 81, which isn't so confusing. Now that everything looks good, um, we're doing so great, except that b isn't technically a number, so that's actually not very great. And that's where we have to plug in the infinity. So my limit as b approaches infinity will be a negative 1 on the top, and on the bottom there is a 3 multiplied by infinity cubed, which is a super big number. So a small number, like 1, divided by a super big number on the bottom will eventually be 0. And that's going to be minus negative 1 over 81, which is the same thing as 0 plus 1 over 81. And of course, you can't forget the pi out in front. I definitely have not done that before. And so my final answer will be pi over 81. Now, for the points, it'll be a point for the setup, a point for noticing that it is an improper integral, so placing that top bound as infinity. Another point for putting in the b and the 3 into the equation, and another point for the final answer. Okay, and we're done with FRQ number 5. We have one more left, FRQ number 6, and I'll post that pretty soon, right before AP Scores will be releasing, which is July 5th. I'm so nervous, but so excited. Anyway, these are my score predictions of what you might need to get at least for a 3, and my score predictions for a 4 or 5. Now, again, these are not the official scores that you need to get, but I've kind of formulated my own based on previous scores. Also, update that the AP College Board has finally revealed all of the score distributions. They usually do so 2 weeks prior to the score release date. And so, if you go into Trevor Packer's Twitter, you can see all the percentages of who got what score for what test. And finally, the Calc ones are out. BC was actually the last one out, so it was well worth the wait, but they're finally here. And the stats are looking pretty good. It was like a 2 to 3 point percent increase, which is awesome. He also tweeted that FRQ number 6 was the hardest one, which is the next FRQ I'll be posting. That was the one with like the alternating error bound or whatever, so I can see why that was a hard one. And apparently less than 1% of kids got a perfect score on that. So, like, wow, that's crazy. And the best FRQ for the Calc BC kids was the second FRQ, which was all about parametrics, where 14% of students got perfect scores on that, which is so crazy. Alright, and thank you for watching my video. Be sure to give this video a thumbs up, subscribe if you learned something new today, and comment if you have any questions. Also, if you took the AP language test and want to know the answers, then check out the video to the left. And if you want to know the answers to the FRQ number 4 for the BC Calculus test, then you can click on the video to the right. Thank you so much for watching my videos. Be sure to stay tuned for any upcoming videos. I'll be posting the rest of the FRQs. I have FRQ number 6 left, which is the hardest one apparently, so I'm so excited. And yeah, make sure to keep learning every day, and bye everyone!